So start where you are and build where you are. Similarly, you can get a free license if you actually wanted to try the Esri platforms. They do, like specifically ArcGIS or ArcGIS Online. That's not necessarily what I'm advocating for here, because I am saying everything is inside of Fabric. But if you did want to explore the larger universe, they do have amazing 6-week MOOCs, massive open online courses, and they do give you a free trial to the software when you're in one of those courses. And then there's GIS Day in November, and a lot of events will give away free 1-year personal licenses. So there's that, and then there's things like QGIS and just other platforms that are free and open source as well. So there's a lot of ways to play without budget. And then, of course, as you use this for yourself professionally, or your team or your department, your enterprise, this scales all the way up in terms of its capabilities. So what is Esri? Founded in 1969. It serves 300,000 plus organizations worldwide. It is the #1 GIS platform globally, and it has provided 50 years of GIS leadership. Esri stands for Environmental Systems Research Institute, again, the world's leading GIS software company. ArcGIS is their flagship platform. It's a complete system for mapping, spatial analysis, and geographic data management. ArcGIS Online is the cloud component, so you get web maps, hosted layers, and apps accessible from a browser or API. And then Esri and Microsoft have a deep 2026 partnership, which I started seeing at the end of 2024 when I saw the marketing departments kind of get out in front of it, but I was not yet seeing what the product was. And then I was fortunate enough to go to Fabric in the spring of 2025, and that's when I saw the rollout. And I was like, okay, I get it now, and I want to be part of this. And then going to Esri UC in the summer and meeting more of the Microsoft team at Esri. And then as I've gotten more and more into the Fabric community, just have seen like, okay, this is my spot. This is my lane. I'm just so excited about this partnership and how I can be an evangelist for it. And then they've got ArcGIS Maps for Power BI, ArcGIS Maps for Microsoft Fabric, and other Azure native services. So this is kind of, and then key concepts, we touched on this, and we'll just kind of, hear them again, is layers, the fundamental unit of geographic data. A layer contains features, points, lines, and polygons, or raster imagery with attributes. So think of it as a table with a geometry column. And that, again, you can list a country name, a state name, a province, a zip code, or longitude, latitude, or other coordinates to have that where, that spatial component. Feature services are web services that expose layers over HTTP as JSON files. And so this is how ArcGIS Online data moves into Fabric. So you query a feature service endpoint to get geometry and attributes. There's web maps, which are saved configurations of layers, base maps, pop-ups, and styling. A web map is an ArcGIS equivalent of a Fabric report, a shareable, a composable view of spatial data. You've got spatial data formats. The shapefile, I've always been told it's not the best or most robust, but it is the most commonly used. So it's that .shp is your, geospatial file you'll often see as shape files. There's GeoJSON, file geodatabases, so GDB, and increasingly GeoParquet files, so Parquet with geometry, and GeoParquet is the Fabric native format for OneLake. We've got coordinate systems. All spatial data has a coordinate reference system, so a CRS, and we typically use the WGS84 is the default for web data. But understanding CRS prevents misaligned layers, so your data does not end up in the middle of the ocean if that is not where it was intended to be. And then geoprocessing tools, so spatial operations, buffers, clips, intersects, dissolve, spatial joins. These are the building blocks of spatial analysis, and they're the equivalent to a SQL for geometry. So we've talked about some of that, continuing that translating. So feature service relates to geospatial semantic model. Layer is a visualized data table. web map, interactive report, geometry, spatial z-axis, the math that grounds data to the earth, and spatial data formats. So optimized storage, it's the underlying structure, kind of holding the coordinates. And what we're seeing now, again, we've got that ArcGIS maps for Power BI, Azure, plus ArcGIS Enterprise, ArcGIS Maps for Microsoft Fabric, and ArcGIS GeoAI, and Azure OpenAI. So all of these are the ways that Esri is now coming together into the Microsoft ecosystem, and specifically into the Fabric. So now let's look at Living Atlas. Living Atlas is super cool, and that's probably why a lot of us are here. It is the largest collection of global geographic information freely available to ArcGIS users. And so you've got a blank map problem. The raw data without geographic context is a dot in the dark. And the coordinates alone are not providing the answers. We need to sort of populate it. And so Living Atlas of the World is data that you can now bring into your Microsoft Fabric environment. And it's bridging the gap between the Medallion architecture and GIS. And so Living Atlas data, when it's published, anybody can publish it, but it is the most authenticated geospatial data. And with that, I think we can actually, I'm going to come and just check in on everybody. And while I'll do that, I'm going to actually, oh, okay, you've got a thing for Living Atlas. I'm actually going to take you on a tour of my Living Atlas. So I'm going to go ahead and do switch our screen up and do a share so that you can see what I see. Okay, so there's Living Atlas. Let's make sure you guys see what I see. Okay, so you should be able to see Living Atlas. Okay, so this is now, we're on the Living Atlas site. It is livingatlas.arcgis.com. Now I am signed in with my ArcGIS account. I still have the benefit of getting a student account since I am just having graduated. Okay, so Foremost Connection, as we just talked about, includes maps, apps, and data layers to support your work. So we're going to Esri UC. That's coming up in mid-July. And they always kind of just have, it's called the Mappiest Week on Earth, or Mappiest Week of the Year. And so it creates ready-to-use content, and they have a thing called the Map Gallery. So you can select demographics from World Population Global. There's you can use Living Atlas to map and analyze local air conditions. It has approximately 40 years of analysis ready for land cover layers. Sorry. NLCD stands for National Land Cover Database for land cover. You've got Global Fishing Watch layers are now available. GBIF species data, so Global Biodiversity Information Facility. You've got, it's got a feed status, ready-to-use services that help enhance situational awareness. So you've got, real-time intelligence. And so you've got layers, scenes, and ArcGIS story maps. Story maps are more kind of like a blog where you can add geospatial information and kind of connect to the maps that you make. And so I use story maps quite a bit. And other tools that you can use for spatial analysis allow you to quantify patterns and relationships in the data and see the results as maps. So maps, layers, and scenes. And then how to use ArcGIS Living Atlas. You can explore the maps, the apps, and the data layers from Esri and thousands of other organizations. You can grab content, combine content with your own data to create new maps and applications, and get inspired and see how others are visualizing data and solving problems. And now I have shown this to you sort of again through my ArcGIS account, but this is the same data that's available if you were to have this enabled within your Fabric tenant. All of this data now is natively accessible through Fabric. So create a new map in seconds by adding layers in the map view, and you can use your own data combined with the layers of the ArcGIS Living Atlas of the world. And again, things in Living Atlas are the most authenticated data. We have, when I work in the ArcGIS Pro software, we have access to what's kind of the ArcGIS Online data, which is basically any data that anybody publishes, but it's not necessarily authenticated. And that's probably one of the biggest challenges with spatial data and all data in general is really the metadata. And just as data science practitioners or GIS professionals, one of the things we all need to do better at is making sure that we're adding good metadata to our data, so it's usable by other people. So here's an article they have of what's new in imagery, what's new in ArcGIS Online. They're adding mapillary global scene imagery. So there's some, just to me, it's always amazing to sort of see all the new developments. Handling non-numeric data values during data cleaning. So just a lot of resources, a lot of information, just tons of stuff to check out. Yeah, just it's like I said, it is just this ecosystem and these universes that I did not even know existed. And then what did I have over here? Oh, over here, this is actually my own Fabric tenant and just a demo that I had put together. Sorry, I'm just jumping topics here, but we were talking about chloropleth maps. That is a chloropleth map where you have those different densities of within polygons in the color gradients. And we'll get to this and come back and look at this, and I'll show you, because this is actually tied to an actual demo that they have. But this actually is, I kind of rewrote the code so that you didn't actually have to have a license for this. It was just actually using it as an unconnected notebook. So the idea is you can actually follow the instructions that are given here as they do this demo, but you can do and create the same map without having the any sort of paid upgrade to it. So there's, oh, and then I love Esri Wayback Machine. You can basically go anywhere in the world, add your address, and then you'll get a time series of how that place has changed. So here we are, and I don't know if it's going to go very quickly here. It doesn't have a lot of data before 2014, but you get to sort of see how things kind of change over time. So that's the Wayback Machine. All right, so I'll come back here. I will stop that, come back here. Okay, so let us continue on. Are there any questions I should be fielding at this point, or I'll march on and then we can come back and I'll take some questions. Okay, so we've covered Living Atlas. You've got demographics, you've got environment, imagery, boundaries, real-time data, base maps. So thousands of authoritative, curated, and ready-to-use global geographic data sets, free with an Esri ArcGIS account. And again, whether you're getting that directly through Esri or you're getting it through your Fabric tenant, the Living Atlas is an amazing resource of spatial data, and you can use it to enrich the data that you already have. So that the idea is that you're not necessarily there to just kind of, you don't need, again, that data is there to sort of add layers and add context and add depth to data that you're already working with. So we talked about medallion architecture, spatial variables treated as core dimensions of the enterprise data catalog. And so trace the life cycle of spatial data through OneLake, applying Esri capabilities at every stage of the medallion architecture. So at the bottom, you've got your raw data, coordinates, features, APIs. You can use ArcGIS REST APIs. Your middle tier is your georeference cleaned geometries and transform projections. And so here, the tool you can use is your ArcGIS GeoAnalytics for Fabric. And then top tier, aggregated spatial metrics via Direct Lake. So you can use ArcGIS Maps for Fabric, ArcGIS for Power BI. And keep that in mind that some of the tools are there for the geoprocessing and other tools are there for the visualization. So base maps are what your map is going to look like, what kind of canvas you're working with. Some of them can be real and look like the actual surface of the earth. Some of them can have labels or not labels. Some of them can be simpler, just a white background or a dark background, or other different designs and illustrations that are used as base maps. And then you've got your topical lines, topographic. This kind of shows us the spaces in points, lines, polygons. And then you can add sort of multispectral imagery, and that's kind of where your base map, again, starts to look like a natural land surface. And then boundaries. So again, I'm starting kind of bottom up. Ecological regions, standardized hexagonal grids, administrative areas. And again, now you're dealing with the kind of polygons and demographics. Can be anything from a tapestry of segmentation, disposable income, population density, and then environment, protected areas, climate data, real-time live feeds. So the insight is that the Living Atlas is the foremost collection of curated global geographic content. It allows you to add environmental and demographic baselines to your internal Fabric data sets without managing the raw data yourself. And ingesting spatial data into OneLake. So it can start as a GeoJSON, moves into your Fabric notebook, Python requests, and goes to OneLake, sort of a Delta Parquet, original CRS, preserved for audit trail. So REST API extraction, so query public feature services directly via an ArcGIS REST API from a Fabric notebook. The format conversion converts spatial payloads, so well-known text, well-known binary GeoJSON into standard Delta Parquet, and preserve the source CRS. So bronze layer ingestion must always preserve the source coordinate system to maintain a flawless data auto trail. So even if you do a transformation of the data, you always want to know where it started. So if there was something not right, you can always kind of know what that original, like where you started. We would have to be careful with our coordinate reference system because native integrations that pull data without CRS discipline produce maps where features are frequently wrong by hundreds of meters. So that's one of the things that's really important to make sure is like that your location on Earth is a true location. So geodesic calculations are highly accurate over long distance, but introduce massive CPU overhead in Spark. Planar calculations transform coordinates to a local projected coordinate system using st_transform, allows for lightweight Pythagorean calculations, significantly decreasing query execution times. So a lot of these stuff you just kind of have to field. Again, how much CPU, how much storage are you going to need for a particular process? I think one of the things I learned, and I will say this as a creative, and I definitely feel like I come to the world as a creative, I like to take the most and then whittle it down to the least. That's just my natural working process. So if I'm doing a research report or anything, I want to kind of understand the boundaries of something, and I want to sort of kind of understand what's the everything, and then whittle until I get my final product. When I did my internship with the U.S. Geological Survey, I was just absolutely destroying my computer storage and its ability to even function by trying that process with satellite imagery. And I was reminded by the scientists there, as I was getting into scientific methodology, start with the least, make sure that works, and then build upon it, and do it that way, so that you're not getting in here using like a huge amount of CPUs, therefore incurring a huge amount of costs. So the way to think about this work is definitely start with smallest and build on it. And I think say the same thing when you look at your paid accounts. You don't need to have a paid subscription yet. There's free trials. There's ways to work and integrate spatial data into your workflows and into your business questions until you can create a use case for it to say, oh, we would like more of this, or to expand what's possible for us. So similarly, in terms of your investment into this, I think at this point you start with a learning investment, and then you just build on it until you get to the subscription or the services or the team capabilities that you need. And so the silver layer transformation is the ArcGIS GeoAnalytics for Fabric. So it's a proprietary Spark native library integrated directly into Fabric's data science and engineering workloads. So runtime 1.3 plus, it operates without separate installation. It features over 150 optimized spatial SQL functions designed to execute parallel operations across distributed Spark clusters. And it's licensed via the Azure Marketplace on a core hours model. And core use is for cleaning geometries, standardizing the CRS to a canonical format like WGS84, and running multi-node spatial operations. And then pre-filtering spatial extents for Spark performance. Spatial calculations are highly memory-intensive operations, as we were just talking about. So to prevent memory bottlenecks on Spark nodes, always filter datasets to a specific bounding box for executing complex spatial joins. So function ST environment intersects. This envelope intersects functions acts as a coarse low compute filter, preventing the Spark engine from processing unnecessary global data when analyzing a local region. So that was my biggest takeaway in working with spatial data. In parallel is I would transform that data through a tool called ESPA. So I get indices like NDVI or NBR, which are vegetation indexes, or post-fire burn. NBR is normalized burn ratio. But I was downloading the entire tile, which was a massive, and it totally changed and optimized my workflow when I learned to clip it to just the bounding box that I needed for my study. And then suddenly, like, my computer did not fight with me or have these memory issues and storage issues that it was having for so long before that. So that's one of the things you have to just be aware with spatial data is it can be quite large. So you definitely want to always know kind of what is your study area, what is your focus, what are your boundaries. And also oftentimes a boundary can be kind of an administrative boundary, the sort of the polygon, or it could be like, and when I say polygon, something that kind of has a very defined shape, like we're looking at the state of Florida, or it can just be 4 points on a coordinate. And sometimes I will even use an LLM to say, what are the coordinates for this? And mostly it's right, sometimes not, but you can definitely check it. I also use Google Earth Engine a lot if I need to pull coordinates from something, and I can just put dots on a map, and then it will tell me what those coordinates are, and I can copy and paste them into anything else that I'm using. Yeah, just definitely learning to clip things and like always start with the least and then build from there. So analytics shifts changes the questions you ask. So let's say as data scientists, we ask questions. So standard BI question could be, which customers churned last month? A spatial question could be, where are churned customers concentrated and what competitors are nearby? A core operation uses joins on exact ID matches, and its spatial equivalent was use proximity, buffers, and containment on geometric overlaps. Pattern recognition in BI can identify trends over time. Here, it can identify hotspots, cold spots, and spatial outliers over geography. And so the gold layer now is ArcGIS Maps for Microsoft Fabric, which is currently in public preview. So we love public preview because it's free. Everybody can go in and play with it. And it's via the Workload Hub. And so it's a flexible browser-based environment within Microsoft Fabric for visual data exploration. The capabilities are instant plot, parquet, GeoJSON from OneLake, features dynamic browser-side data clustering that redraws on the fly, smart mapping for automatic visual hierarchy, and an AI-powered arcade scripting assistant for natural language calculations. And that's what we're also seeing like more and more in GIS is like last year's conference was an entire conference on GeoAI, which had not been the theme in previous years. And GeoAI is not just that the systems are using AI in their geoprocessing, but that you can use natural language to say, hey, what do I do next? Inside of our, like, for example, ArcGIS software, they're just kind of rolling that out right now. But I've always used my LLMs to see if they can help me solve problems. And sometimes they can, sometimes they can't. But I'd definitely move along further with the help of our AI. And so if you have questions, don't hesitate to use your AI to help you answer them. So executive dashboarding, ArcGIS for Power BI, for enterprise distribution, spatial insights flow into Power BI. By utilizing the medallion architecture gold layer, Power BI can bind to Delta Parquet files via direct lake mode. So bypass slow import or direct query models. The ArcGIS visual renders real-time spatial indicators alongside standard corporate metrics, includes interactive reference layers and cross-visual filtering. So selecting a map drive time area filters the adjacent tabular charts. So we've got ArcGIS Geoanalytics for Fabric. It's for kind of a data engineer, data scientist, and your environment is going to be PySpark notebooks and Data Factory. And your core action is pro code, batch transformations, massive scale spatial joins using the st_transform. You've got your ArcGIS maps for Microsoft Fabric. This is your persona here is data analyst, business analyst. The environment is your Fabric workspace, SaaS workload. Your core actions are low-code visual exploration, dynamic clustering, and native web maps. And you've got ArcGIS for Power BI. Your persona is your executive customer, your BI developer. Environment is Power BI report canvas, and your core action is no-code dashboarding, cross-visual filtering, and KPI context. And context demand. So we've got real-time live feeds of traffic, weather, events, and infrastructure, imagery, high-resolution satellite and aerial captures, environment, climate, weather, and ecological tracking, demographics, population, income, and lifestyle metrics, boundaries, administrative and demographic borders, base maps we talked about are those foundational canvases. And all of that kind of is can now be part of your One Lake data. Although I would say there are limitations on the imagery, does not do as well yet with raster data. So we focus more on vectors, points, lines, and polygons. And then if you're just starting out, that is where you want to start. And again, the other ones just are just huge storage, memory, and CPU capacities. So not necessarily the best place to start because they're just, again, these massive files that you're working with. And even in my own like ArcGIS learning journey, we started with our vector data, got really, really good at that. And then later I built upon that with the remote sensing and the satellite imagery and then adding sort of GeoAI and machine learning processes to that. And I have a whole workflow that I teach on that. So we talked about accessing that Living Atlas content, the browse and discover. Again, probably one of the, if you don't have a Fabric license and you don't have access to ArcGIS through Fabric, the MOOCs are fantastic and they will be coming around again, I think in late August and September. And that gives you free access into the kind of an esri license for the time of that course. And that would actually give you more opportunities. So you can go to Living Atlas on the outside without sort of being logged in and just kind of learn more about Living Atlas. And you should, because there's a lot of really great stuff there. But in order to sort of download and work with those data sets, that requires a license, but you can still access that through either a temporary license or a personal license. But definitely encourage you to browse and discover sort of through ArcGIS Online. And then you can filter by category, keyword, region, data type, and then you can preview any layer before using it. You can add it to the web map, add selected layer to an ArcGIS online web map, or bring it into your Fabric workflow and configure visibility, time settings, and pop-ups, save and share the web map to your org. Connect to Fabric, use ArcGIS Maps for Microsoft Fabric to bring a layer into Lakehouse, query the feature services via REST API in the Fabric notebook, and export to GeoParquet for One Lake. So enriching your One Lake data with Living Atlas, practical examples, so adding geographic context to your organization's data. So now you can bring in customer demographics, so One Lake customer address table in Lakehouse, Living Atlas, census demographic boundaries, so income, age, population density. And the result would be spatially joined customers to census tracts enriched with ACS demographic attributes for market segmentation. Another example would be a kind of a climate risk scoring. So in One Lake, you've got a property portfolio with latitude and longitude. In Atlas, you've got FEMA flood zones, wildfire risk, and sea level rise projections. And the result is an overlay properties against risk layers. So score each asset by climate exposure for ESG and insurance workflows. Site selection. You can have in One Lake your candidate site locations in One Lake. In Living Atlas, you can look at traffic, demographics, competitor locations, and infrastructure. And the result is a spatial multi-criteria analysis in Fabric, where you rank sites by weighted geographic criteria. And you can do real-time operational awareness. So in One Lake, you have field sensor data streaming into Fabric. In Living Atlas, you have live weather, traffic, and event layers. And the result is contextualize IoT sensor data with real-time Esri feeds, dynamic operational dashboards in Power BI. So that's an example of kind of how enriching your data with Living Atlas, again, is working with what you're already working with, just doing more with it. So we talked about ArcGIS Online, Cloud GIS that powers your Living Atlas access and map sharing. So ArcGIS Online at a glance is cloud-hosted GIS platform, so there's nothing to install. It's accessible via a browser API. It's the home of your organization's maps, layers, apps, and dashboards. It's the access point for the Living Atlas of the world. It's the connection layer between Esri tools and Microsoft Fabric. It supports Python through the ArcGIS library, REST APIs. OGC is the Open Geographic Consortium standards, which is WFS, WMS, and OGC features. And it's and there are free public accounts available. So that's most living content can be accessed immediately. You have to look closer into sort of, again, what's free and what's free, but definitely explore until you sort of get to a gate. And then I would say only kind of move past that gate when you're ready to get to that next level, again, for yourself, your team, your department, or your org. And so what you can access without a paid license, public Living Atlas layers. So again, some, but not all. This will include base map boundaries and many demographic layers. ArcGIS REST APIs, so query public feature services from a Fabric notebook. ArcGIS maps for Power BI. Free visual basic Esri base maps in your reports. And ArcGIS Online free account. You can create web maps, save, and share. Paid add-ons, so subscribe Living Atlas content is going to give you premium demographics, Landsat imagery, and real-time feeds. ArcGIS maps for Microsoft Fabric full integration will require an org account, and spatial analysis credits for hosted geoprocessing tools. So now we see all of the ways that we can sort of put these layers of data on top of your One Lake business data. So you can enrich your One Lake data instantly by stacking Living Atlas layers over your business data. So a single spatial join adds demographic, lifestyle, environmental context without a complex ETL. With that, I'm going to come back to the chat. I think there was a question. Okay, so I do see a question, which was, is the Euclidean distance used in geospatial calculations like clustering? So first, let's define Euclidean distance. So Euclidean distance is, as the crow flies, it's the shortest line between two places. So it doesn't account for the bridge, the river, the road, it just is what's the straight line, not what's the driving distance. The next question is geospatial calculations. Yes, because you would want to know the distance. Yeah, absolutely, Euclidean distance is used. When you say like clustering, clustering is more like, I think of a heat map. And so it's more visual, like you see it. But if you wanted to measure the clusters, so let's say you had a cluster on one side of town and one on another side of town, and you weren't necessarily looking for the drive distance, which is another network analysis that you could do to say how long would it take me to get from one of these clusters on one side of town to the other. That would be one calculation. Or Euclidean, you could just say, what's the straight line between these two clusters? Absolutely. So hopefully that answers that question. And yeah, if you have any other questions, please feel free to bring them to my attention and I will answer them to the best of my ability. Or find resources where I can point you where they can be answered. So connecting ArcGIS Online to Microsoft Fabric. ArcGIS Maps for Fabric, there's a native connector, visual integrate in Fabric Workspace, and it does require an ArcGIS account. REST API for notebooks, query feature services with Python requests or ArcGIS library, works with a free account and public layers, or GeoJSON and GeoParquet export. Download layers as GeoJSON, which you can get just from other sources, and upload to OneLake and convert to GeoParquet with GeoPandas or PyArrow. And then kind of this gives just a code example of REST API in Fabric Notebooks. You import your requests, GeoPandas, and then bring in your URL and your GDF, and it's a kind of example. So seamless artifact sharing, build the spatial foundations in ArcGIS Online, and publish and share them to ArcGIS Maps for Microsoft Fabric. So build the spatial foundation, consume and interact with the finalized layers directly via ArcGIS Maps for Microsoft Fabric inside your Power BI workspaces. And so again, we talk about licensing. Just explore and see what you have, what you're working with, what you can add. And again, with all of this, there's free places to learn and apply this, and then there's just different gates along the way. And again, a lot of it depends on what you're doing. Some of the more robust licenses. So for example, I was playing with the GeoAnalytics when it was in public preview because we love public preview, it's free. Only to find when I went to continue working with GeoAnalytics, it had gone to its enterprise fee gate, which was, I believe, over $1,000 a month, and that was not in my budget or my use because I didn't need that many CPUs and I was not working at enterprise scale. So a lot of the budgets, costs to these things do sort of match the value that they bring to an organization. So there's enterprise scale spatial analysis, which again, you can bring in private organization data layers, premium demographics, enrichment, and advanced analytical operations. But before that, see what you can find and have access to, because there's still a lot of living atlas that's available to you, including basic, and then basic base maps, public sharing, and foundational mapping within Power BI. So it's perfect for sort of that intermediate prototyping. So we've looked at space. Now we'll look at some of the spatial analysis for Fabric, how geometry changes the questions you can ask for your data. So with Standard BI, what were the total sales for Q3? Location Intelligence asks, which underperforming stores locations sit within a 15-minute drive time of our highest churn demographic? And that goes back to the Euclidean distance question, because you can do it with drive time, or you can just say 5 miles, which would be more of a Euclidean. You're not asking for 5 miles of road. You're just saying kind of as the crow flies. So Standard BI answers what happened. Spatial analysis answered why it happened there. So the dimensions are a core question, a primary join key, key operations, and outputs. And in your Standard BI analytics, you've got what and when, you've got foreign keys, exact matches, you've got aggregations and rollups, and you've got charts and tables. And so as we translate them, the core question of what and when becomes where and how close. The primary join key, in this case, becomes spatial intersections and geographic overlaps. So you can have things that intersect, things that touch, things that, so it's, or things that are within or outside of. So we just kind of use different languages when we're working with space. Key operations are going to be aggregations and rollups. And here they become proximity and overlays. Like you can do buffers, how far, what is in a catchment area. And your output for standard BI is your charts and tables. And here it's going to be geometries and heat maps or point density. Again, you're working with points, lines, and polygons. So that's your answers are going to all sort of be within a visualization of points, lines, and polygons. So what is spatial analysis? BI analysts ask, how much revenue did we generate last quarter? Which customers have churned in the last 30 days? What products are selling best by category? And the spatial analysis asks, where are churn customers concentrated and what's nearby? Which store locations have the highest at-risk populations within 5 miles? And how does revenue change as you move away from urban centers? And our core spatial operations are proximity. So we've got buffer zones, nearest neighbor, distance calculations, clustering, identifying hotspots, cold spots, spatial outliers with spatial autocorrelation, overlay, it intersects, unions, clip, combine layers to answer compound spatial questions, density, kernel density estimation, visualize where features concentrate in space, and network, route optimization, service area analysis, and time travel polygons are some of the examples. So GeoParquet and open formats in OneLake. So the emerging standard for spatial data in cloud lakehouses. What is GeoParquet? GeoParquet extends the Apache Parquet columnar format to natively store geometry. Points, lines, polygons using WKB, well-known binary encoding. It brings geospatial data into the same storage platform as all other Fabric Lakehouse tables. A GeoParquet file in OneLake is just a Parquet file. Your Spark SQL queries work immediately, and your geometry column and spatial functions do the rest. So with geospatial format comparison for Fabric users, your format, GeoParquet, GeoJSON, shapefile, or file GDB. Fabric native, yes for GeoParquet. GeoJSON is via notebook. Shapefile, no, that's legacy and works more within GIS systems. And file GDB, no, that's going to be, your geospatial database. That's going to be Esri only. And so GeoParquet is best for OneLake storage and Spark analysis. GeoJSON's best for API responses and small data sets. Shapefiles are kind of part of the interoperability and Esri workflows. And geospatial databases are more of a complex Esri feature classes. And here's some sort of sample code. And we're going to just in a second jump to our demo, and I'll show you again what sort of that code starts to look like in the notebook. Spatial analysis results back into Fabric. So closing the loop, analysis output as Fabric artifacts. So you've got your Fabric Lakehouse data, customer, property, sensor, or operational data with address or latitude, longitude fields in OneLake. You've got spatial analysis, buffer, cluster, density, network in ArcGIS Pro, ArcGIS Online hosted analysis, or PySpark, GeoPandas in Fabric Notebook. You've got an enriched output, so the results written back into OneLake as GeoParquet or data tables, geometry plus original attributes plus new spatial metrics. And then visualizations, your Power BI and ArcGIS Visual. Spatial results surfaced in Power BI using ArcGIS Maps for Power BI Visual. Interactive maps with full drill through. And your 5 core operations of data science, just again, getting you thinking kind of as location intelligence professionals. Think in terms of proximity, clustering, overlay, density, and network analysis. So these are all ways in which you can think about and apply geospatial analysis to your data. So you're wondering how close things are, how do they group and form, what intersects, overlays, kind of touches, is within, without. Dot density is a big one. How do things concentrate or disperse? And then network analysis. How do we optimize a route or try and time travel with that or service coverage? So different ways in which you can now answer and think in terms of how these types of visualizations can help answer your business and organization's most important questions. So the native spatial data in Lakehouse, so GRPK brings open geospatial format directly into OneLake, store rich spatial geometries alongside of tabular data, optimized for massive scale, and completely ready for downstream AI workflows. So now we've got this kind of unified data workflow between your raw OneLake data, the spatial analysis in ArcGIS, and it can be enriched by a living atlas and then published to BI reports. So from OneLake to location intelligence and back, a continuous cycle of extraction, spatial enrichment, analysis, and visualization. Now let's get into, I'm going to give you a demo in a minute. But this is, let's kind of just look for, let's do a walkthrough before I take you over to the demo. So here's a scenario of a property insurance company needs to assess the potential impact of an incoming natural disaster on their active policy portfolio. The goal is to take raw policy data in Fabric, enrich it with Esri environmental layers, run spatial intersect analytics, and visualize the financial risk, all without leaving OneLake. So step 1, ingest and enrich, which is the bronze layer. So the action is the organization's active insurance policies, the tabular data, are loaded into OneLake. The enrichment is using Living Atlas integration. We pull live hurricane storm tracks and historical flood zone boundaries directly into the Fabric environment. The raw GeoJSON is saved as bronze delta parquet. Step 2 is we transform and clean at the silver layer. So the action is a Fabric Spark notebook is triggered. Code execution, st underscore and environment intersects, is applied to drop any global weather data outside the target state boundary, saving memory. St underscore transform converts the storm track geometries from geodesic to a local planar coordinate system, enabling high-speed calculation. Step 3, analyze and aggregate. Now we're at the gold level. So the action is using ArcGIS GeoAnalytics for Fabric. A spatial buffer is created around a forecasted storm path. The join and STL underscore intersects join is executed between the buffer polygon and the policy points. Output, a gold delta parquet table is written back to OneLake, containing only the at-risk policies and aggregating their total insured value. And step 4 is visualize and share the action. So here we start with Power BI connects to the gold data table via direct link mode, ensuring zero data duplication and zero latency. The result is the executive team views an ArcGIS for Power BI report showing exact property locations relative to the hazard, with dynamic infographic cards automatically updating total financial exposure as the storm tracks live updates. So we create a unified system of record. An integration done right respects coordinate discipline, leverages native Spark processing, and keeps spatial dimensions as first-class members of the gold layer. ArcGIS remains your spatial system of record. Microsoft Fabric is your enterprise analytical engine, and together they eliminate silos and turn location from a static attribute into your most powerful analytical dimension. So with that, we are going to, I'll come back to that. Okay, I'm gonna just come back for a second. Let me check in with my mods. How are you all doing? Do we have any questions? Because I'm gonna now kind of just take you through a very simple notebook and demo. Lee, how's it all going in the chat? I don't see what's going on in the chat.
Chats are quite okay. We're still answering all the questions that we have. Most of them are attendance questions and then vouchers, so we'll be answering that soon.
Yes, definitely. Thank you. Yes, we're excited to be able to share the vouchers, and we'd love to see everybody get certified DP 600, 700, 800. You can get 100% off. PL 300, and then there's another one that are 50% off. So yes, we're excited to share that with you. Yeah, it's all the data days, has all the information, and we'll give you the exact links as well as we wrap out the session, and then I'll send them through as a follow-up. Great. And excited. Yeah, just so happy that everybody is here, and I thank you guys so much for managing that. And all right, let us go ahead and do a demo. Okay, so you should see my screen now. And I'm going to come over, where am I at? Here we are. Okay, so this is part of developers.arcgis.com, the geoanalytics fabric get started. And this is really kind of answers, how would one get started on the geoanalytics for Microsoft. Now, again, I think that this is a good place to see kind of what some of the capabilities are, but be aware that some of the geoanalytics definitely sort of moves very quickly to enterprise. So what I have done is actually take this particular notebook and enabled some of the functionality within Fabric, but still am not on a paid plan and still was able to get it to work with a few modifications. But following this kind of Python import geoanalytics fabric, import geoanalytics underscore fabric SQL, and import functions as ST, and Spark SQL, and so show user functions like ST underscore, and then whatever follows is the, and then import geoanalytics fabric. So I've done that, and then we create our data frames. And here, the goal of this particular inquiry is looking at population density in the US state of Georgia, which basically is very much around the city of Atlanta. And so here we're just, again, pulling in code, and now the result is it's starting to give you the object ID, the name, state abbreviation, state FIPS, county FIPS, FIPS, population per square mile, square miles, shape area, shape length, and shape polygon. And so now it's going to introduce using functions as tools, and there's some more code. And now it starts to introduce kind of what is the center point of each of the counties, which is the centroid. And then it's going to now start bringing in the coordinates of longitude and latitude for each of these center points. And it's going to now give us, here we've got counties, but these are of different states that I'm not sure what, but we're exploring the results. My understanding is we're only looking at Georgia, so not sure what that other one is telling us, but here we get to here, and this is where and how the population is in Georgia, where you can see the highest concentration of population density is in and around Atlanta. And then they sort of share other places to continue our learning journey. So now I'm going to bring you into my own Fabric environment, and let's see what I created here. So here I kind of followed along in bringing in those that code, their initial code that they instructed us, and similarly, we get our geometry is starting to take place. Now I have imported the geoanalytics for Fabric, and it's downloaded all of that. Now I'm importing ArcGIS, import GIS, and I have done that. Now I've created my own, so it's giving me information about different counties. I think for some reason I started with Alabama, but now we get ourselves to Georgia. So here we are in Georgia. Now we have all the counties, and we have the population, and we have the population per square mile. And then we have importing our GeoPandas, and now working with our geo data frame. So now I have the different counties, their populations, and their square mile, specifically for Georgia. And now we're adding in the coordinates, and we're finding the centroid. What is that center the center of each state? What is that longitude and latitude? And then we are here, and now we have our population by counties. So this was a kind of a notebook that I created and ran without, with kind of the minimum access to what is in the, what is available in our Fabric environment. Okay, so that brings us back to the idea that I just encourage you all to start making maps. And I always like to sort of say, think about being a map reader, a map leader, and a map maker. And making the maps might take a minute, but it really actually, like I said, in the simplest form, like the chloroplast map that we just saw, you can start playing with some of this in your own LLMs, just whether you're working with Claude or you're working with ChatGPT or Copilot or Perplexity or whatever your favorite LLM is. It can help you make a map and start thinking about spatial questions that you want to start answering. And I also say map reader, meaning start to look at maps, start to understand what the underlying data set is, start to understand just giving it language, like what kind of base map did they use, what kind of spatial question are they answering, what kind of decision are they encouraging you towards, or what's the kind of conclusion of the map. So think in terms of that as you are entering this world of adding location intelligence to your workflows. So some of the things that you can do on your own is browse the Living Atlas in whatever kind of level of access you have available to you. See what's there, explore, read the articles, look at the data, and then start thinking about how that data connects to the data that you're already working with. Open ArcGIS online and see what's there. You can start kind of querying in a Fabric notebook, and you'll have access, like I said, that there's the notebook that I created, which was kind of a modification that I was able to sort of run and get to work in Fabric without having the full geoanalytics enabled, but still following their instructions with some modifications. And that is to say, like when it was in public preview, I could run that notebook exactly as is and everything worked. But when it came out of public preview, it broke on me. And that's why I had to sort of configure it, but still could get it to do that obviously a very simple analysis. But the idea is just to get you started on making some maps. You can sort of then start working with spatial joins to business, now connecting this third-party data to your own data, and then starting to see what you can, then you can sort of write back and visualize it and start, again, this is now, making your own maps and your own Power BI projects. And I'm here for it. I absolutely love to teach and share all this stuff. So, and answer questions and just be a resource. And the biggest goal of mine is building community around this. So community is really big for me. And I just think there's an amazing opportunity for us to kind of all be in this together and learn this together. Then I'm a recent graduate, just finished my third and final master's that have kind of taken me through urban planning and GIS, and then wrapped up with cybersecurity, just because I felt if I was going to work with data and my particular interest is in government, that I should learn how to keep that data secure. So that is how we became to be the location intelligence and security user group, because I think both of those things are kind of important and kind of are really natural extensions to what we're already doing as data scientists. But maybe as we come up in data science, it's not the primary things that are focused on. So yeah, I want you to have that opportunity to check out what Esri does. And like I said, we've got my like Esri shirt, which is kind of why you got me in a baseball shirt today. I was like, I will bring my Esri swag. And of course, we have our Globie, and I'm going to hang out with all of his people at the Esri User Conference coming up, which I'm super excited about. And then we've got, Microsoft Learn. They have different resources there. There's one lake documentation, and there's now a lot more coming out since they're rolling out the ArcGIS maps for Power BI documentations and ArcGIS maps for Fabric. So there's a lot that we can continue to explore and do deeper dives into on those very specific things. This was meant to be kind of an overview of getting to know Esri, just because I feel like many people who come into data science from the traditional data science paths are not introduced to Esri. So hopefully this gave you a really good insight into what's possible. And just to understand, the Esri User Conference, I believe, has 20 to 30,000 plus attend every year. So it is the biggest geospatial conference, and it'll be, like I said, my 4th year attending, and I absolutely love it. And I'm there for the whole week and get so much out of it. And just we're all part of a community, and wanting to now extend that community. And I'm just really happy to also be part of the Fabric community, and again, putting these two worlds together, and that's already happening. So I figured, why not, share my passion and expertise in this space. There's open source, GeoPandas, GeoParquet, Apache, and then of course there's certifications. I'm actually going to be getting my Esri certifications, but you are all here. We want to get you your DP600s, DP700s, DP800s, and that's it. It's time for questions. Yeah, we just basically want everybody, whether you're a data engineer, Fabric architect, Power BI developer, GIS analyst, to sort of all kind of come into this tent together, and we can sort of explore these concepts of location intelligence as applied to the Fabric ecosystem, and of course security, which comes up again in many of our upcoming talks. And that's actually one of the reasons we're going to actually look at KQL, because in my studies I kept coming across KQL, the Kusto query language, and a lot of the real-time intelligence. And then also because when you look at cybersecurity logs, that's also real-time intelligence. And so KQL was coming up a lot in my cybersecurity studies. And I was like, oh, okay, I think we should have a conversation where we can bring together our data professionals with our security professionals and talk about security in the context of Microsoft Fabric. Okay, so data days. Our next Tuesday, we'll be here for data and AI security and governance in Microsoft Fabric. Then we continue on with Fabric IQ. And then we'll wrap up with KQL for data and security professionals. And in the meantime, we have one of our Saturday events we're going to be doing called Win in the Seams, which again is also looking at those intersectional areas. So go deeper. There's Esri trainings, there ArcGIS documentation, and of course, being part of the Microsoft Fabric community. And I just thank you guys all for being here. Encourage you to check out getting a free Microsoft or free Esri account through arcgis.com and browse that living atlas. Run REST API notebook snippets. You can run public query service layers into your Fabric notebook. And then we invite you to join us for our data and AI security governance this time next week. Now, let's look at where you can get all the information. Where you can get your certification codes. And yes, this event counts. If you are, they do ask that you attend events, and this is definitely a qualifying event. So go to Data Days to learn about our 100 plus live and on-demand sessions. Register to get your free Fabric and SQL exam vouchers. The DP800, which is the AI-enabled SQL, is brand new, so definitely highly recommend that. They have study groups for these certifications and tons of other contests and hands-on opportunities, and just so love having you be part of our community. To get your Fabric and SQL vouchers, go to ak.ms/GFD, which actually stands for Global Fabric Day, cert. And this is just one of a couple ways. So this is actually we did our Global Fabric Day event this last Saturday. So this is just one path. These are on a first come, first serve basis, or there's other certification pathways that you can get directly through Fabric Data Days. And then, yeah, this was also an extension of our Global Fabric Day. This was the 50% discount on the PL300 or the DP900 before September 30th. and use https://is.gd/MVW capital and lowercase VWV. And again, I'll do my best to make sure you have some robust post-event resources. And with that, I'm going to come back into the chat. We have about 5 minutes left in our time together, and just checking in with our mods. And I do see some questions, which I'll take as well. I'm going to actually move our slide to the data days, because data days is going to give you the maximum everything. So, okay, so questions. What are the most important fundamentals of spatial analysis that a BI or Fabric user should understand? I think one of the things that I'm trying to communicate is that you do not need to be a GIS professional, and you're not working towards being a GIS professional. There are some clear boundaries between the two disciplines. It's just basically being the best that you can be and putting some new tools in your toolkit so that you can do more, and that by expanding your language, you can actually now have better conversations with your GIS colleagues. And there'll be plenty of work that is squarely in their domain, and there's plenty of work that's in your domain that they don't do. So we're not trying to replace each other. We're just trying to expand the field between these two disciplines and sort of break down some of the silos that have currently existed, where people think, oh, if that has to do with a map, that's not me, that's someone else. And it's like, and to sort of bring it into your discipline to say, oh, if it has to do with a basic map, I can do that. I can figure that out. I can share that. I can ask new questions that I've not been able to ask before with my data, or there is a location column that I'm working with, and I don't need to ignore that and think that belongs to someone else. I can see what I can do with it. And so as far as the fundamentals concerned, is two things you have to remember is like we live on a bumpy ellipsoid, and now we're sort of projecting that onto a flat map. And that's why coordinate systems to sort of identify, well, first of all, on the globe, like where, and then when you take that where it exists on the globe, you then have to kind of figure out where it exists on a flat map, and there's always going to be distortion. And so that's where coordinate systems and projections come into place. And there's levels of complexity to them that you don't have to worry about. Just understand the basics, that if you do find that you have data floating in the ocean or somewhere that does not belong, that there may be, that sometimes when you pull in data, it comes in with different coordinate systems, and things have to be, there's certain, well, different coordinate systems, but it comes in also with different projections. And that's why you may need to reproject your data to make sure that it's all aligned and nothing's misaligned. Those are some of the basic concepts. And I guess the easiest way to make a map is, to get started is make a map. Make the simplest map. Like just play with your LLM and ask it to help you make a map. It can even create the data set. And one of the simplest things to think about is just population density. So take the city that you live in and the administrative boundaries and some basic population data, and just visualize that. It's a great sort of first step to start to make a map. And if you have, like sometimes you can even, like I said, ask your LLM to generate the data set for you. And then you can use like a very simple tool like Geoda will immediately, you just upload that data and just set your colors and you have a map. Or even, like I said, your LLM can build, there's lots of ways to get started. Can you share an example of how Living Atlas of the world provides authoritative data that Fabric users can immediately leverage? Well, I would say demographics is oftentimes a good first layer to understand. Do you want to understand your customers? Do you want to understand different income levels of where of who your customers are? Or maybe you're looking at crime rates, or whether you're looking at locations. You're looking to sort of do a site locator of where you might put a store. It helps to know, like, are your type of customers in that neighborhood? Or are there other competitors located there? Or is that kind of a desert that doesn't have what you have to offer, and it would be an optimal location? So I think that there's demographic data is probably usually the easiest first type of data to enrich your data with, to just get to know the people you serve and what their needs are and what like sort of that population density concentrations are. Where is it dense and where does it dissipate? But you can also start doing that with other assets of pretty much anything. But demographics, I think, is a good first place to start. I have been going for 90 minutes, so I needed a sip of water. And we are at the top of the hour. So any last questions? Otherwise, I will break. And thank you all so much for being here. All right, my voice has just done me in. So I'm going to end it here. Thank you, everybody, and we'll see you next time.